Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. This lecture is of important notes of P1. For this lecture, I am using the work of my best student, Miss Iman Anwar of class 2021, the Lyceum. An important advice: be simple yet graceful. Differentiation. To differentiate under root, we write 1 upon 2 same root, and then we multiply this whole fraction with the differential of this function. This is the easiest way to differentiate under root. To differentiate this equation, we have to write dy upon dx on left side, because the differential of y is dy upon dx, and this will become 1 upon 2 under root, and then we need to multiply this whole fraction with the differential of this function, which is minus 3. This is composite function. To differentiate composite function, we first copy the function, then we make this power coefficient, and then we subtract this power by 1, and then we multiply this expansion with the differential of this function. This is the differential of this function. This question is very important. Find the stationary value of dy upon dx, where x is positive. To get the stationary value of dy upon dx, we need to differentiate dy upon dx first. And this is the differential of dy upon dx. And then we need to equate this second derivative to 0 to get the x coordinate of the stationary point. This is the x coordinate. For the stationary value, we need to substitute this x coordinate into this equation. So when we will substitute 10 root 2 into this equation, we will get the y coordinate of the stationary value, vertical coordinate of the stationary value. So this is the stationary value of dy upon dx. This is the vertical coordinate, h comma k. So this is h and this is k. So this question is very important. Whenever they say find the stationary value of dy upon dx, then first differentiate it, then equate its second differential to 0 for the x coordinate, and then substitute x coordinate into equation of dy upon dx to get the stationary value. Well, for increasing functions, gradient is always positive. If the question is show that the function is increasing, then you have to prove that gradient is positive. Or if they say given that the function is increasing, find the range of values of x, then use this. For decreasing functions, gradient is negative. This is in general. For quadratic increasing functions, then we observe gradient at x greater than h. At x greater than h, gradient must be positive. For quadratic decreasing functions, gradient must be negative at x greater than h. So we observe the sign of gradient at x greater than h in both the cases. For neither increasing nor decreasing functions, we have to observe the sign of gradient at 3 values of x. For example, if we have this gradient 3x minus 2, and let's suppose this is the domain x greater than minus 1, then we need to observe gradient at 3 values of x. For example, at x0 gradient is minus 2. Then we need to observe gradient at x1, it is positive, Then we need to observe gradient at x2. It will be 3 to the 6 minus 2 makes 4. See, gradient is negative and positive. So when gradient is negative and positive, or negative, then we say the function is neither. So this means neither function. For increasing function, gradient will be positive throughout, and for decreasing function, gradient will be negative throughout the given values of x. Integration, the next topic. Well, since this function is non-linear because of this power 2, so you have to expand it to integrate this function. So first expand it and then integrate it, because this function is non-linear. If the function is linear, for example 1 plus 2x, then you can directly integrate it, like 1 plus 2x power 3, 3 into 2. So when function is linear, you should integrate it directly. But when function is non-linear, then always expand it and then integrate it. Another example. This is the gradient and we need equation of curve. Number one, we need to simplify this. This is the simplified form of this function. When you will integrate left side, you will get y, and when you will integrate this right side, you will get this thing. 12x power 4 over 4. This will become x power minus 1 over minus 1 plus c. So this is the equation of the curve in terms of c, general equation. If they will give you the values of any point, let's suppose 1, 2, then you can get the value of c. So this is the general solution. This question is very important. Well, we have second derivative and we have maximum point. Maximum point or minimum point or a stationary point, they all means gradient is 0 at this particular value of x. So this given information means gradient is 0 at x minus 1 upon 3. Since we have to find equation of the curve, so we have to integrate this twice. So this is the simplified form of this equation. When you will integrate this on first time, you will get dy upon dx. And this will this will become 2x power minus 2 over minus 2 plus c. Now, with the help of this information, this one, we can get the value of c. So gradient is 0 at x minus 1 upon 3. Let me write this here. This means dy upon dx is 0 at x minus 1 upon 3. And we use this information here to get the value of c, which is 9. Now we have to substitute this c here. So this is the equation of dy upon dx. Now we have to integrate this to get y. So when you will integrate this thing, you will get y here, and this will become x power, let me check this. This is minus 2. So this will become x power minus 1 over minus 1. This will become 9x, and this is the new constant. And since we have this point, so by substituting this point into this equation, we can get the value of d, which is 0. Hence, this is the equation of the curve. So please check the solution again. When you will integrate this on first time, you will get this equation. And you have to use this information to get the value of c. And then substitute c back into this equation. And then integrate it. And then use this point and get the value of this new constant d. And this is the required equation of the curve. Applications of integration. If you need area, like this area, then you have to use this formula. Area between curve and x-axis. And if you need volume, then you need to use this formula. You just need to add pi here and add power 1. Like you need to replace y by y square and multiply this entire thing with pi. So if you know the formula of area, you can easily make the formula of volume. Just add 1 in this power, you'll get y power 2 and multiply this whole thing with pi. And we use these two formulas when we have to find area and volume about x-axis. And when we need area between curve and y-axis, then we use this formula. See, this is x-axis, so we have dx here, and these two are always opposite. Since we have y-axis here, so we have dy here, and these two are always opposite. Angle between two lines. If we need angle between two lines, then we should use this formula. Tan theta m1 minus m2 divided by 1 plus m1 m2. And m1 is greater than m2. If we have these two lines, L1 and L2, then the greater gradient is m1. The larger gradient is always m1. For example, we have two gradients, 2 and 3. So this will be m1 and this will be m2. So by using this formula, we can get angle between two lines. What if we need angle between line and x-axis? Given line and x-axis. Since the gradient of x-axis is 0, therefore, when we will substitute m2 0 into this formula, we will get this formula. So if we need angle between line and x-axis, then you should use this formula. You can also use this formula, but you can use this formula to make the calculation simple and fast. And one very important thing. What if we have this line and we need its angle from x-axis? Then this is the rough sketch of this line. So gradient is -3 and intercept is 2. So we need this angle. So you have to use tan theta gradient, which is -3. So theta is tan inverse -3. Listen, whenever we work for theta, we take negative sign. If we work for alpha, what if we had to find alpha? Then we always ignore this negative. So while working for the basic angle, always ignore negative. But while working for the general angle, then always take negative. So you'll get your answer. Negative with negative sign. I don't have calculator, you can do this yourself. 1 decimal place in degrees. So you have to take the negative sign while finding the angle. And you will find both the answers in marking scheme. You will find negative answer. Let's suppose this number is 50.3, for example. Then you will find this answer as well in the marking scheme, 180 minus 50.3. So both answers are fine. But it's better to give negative answer because gradient is negative. So this is the better way. Take the negative sign while finding the angle. So angle between two lines. For angle between two lines, use this formula and make sure you take m1 as the larger gradient. m1 is greater than m2. When we need angle between line and x-axis, then use this formula. And this is the example. If we have negative sign, take the negative sign. Next topic is quadratics. This is very important. When we have lesser sign, then always write answer in this way, combined way, between. Write the smaller value here and larger value here. From this bracket you will get x2, from this bracket you will get -3. So write your answer in this way, smaller, larger. So whenever we have greater sign, after this step, always state your solution in this way. And whenever we have greater sign, then always state your answer in this way or this way. This is the smaller value and this is the larger value. So make sure you write your solutions in the right way according to the given sign of inequality. Next topic is functions. So if we need the coordinates of turning point, then always equate this bracket to 0. When you will equate this bracket to 0, then you will get the right x coordinate of the turning point, which is half. And this is the y coordinate of the turning point. So write S. S means stationary point with coordinates half and 9. Now, what's the domain of this function? If the question is find the domain of this function, so this function is happy face. So the domain of this function is x can take all real values. And range is very simple. See, y is increasing from this 9. So for range, just observe the trend of values of y. Since y is increasing from 9 on both sides of the curve with respect to turning point, therefore the range will be y greater or equal to 9. Make sure you must write equal sign. When domain is this, then always write equal sign. This means all points are on the curve. So turning point is inclusive. So this equal is compulsory when we have this type of domain. Inverse functions. Well, if the question is state the largest value of k for which this function is 1, 1, or this function has an inverse. This question usually come in this way: find the largest value of k for which the function f has an inverse, for which f has an inverse, or you can say f is 1, 1. So this is the x coordinate of the turning point. If you make the rough sketch of this function with respect to this domain, you will get this curve. And the coordinates of turning point are half, 9. So your x is half. So this means domain of 1, 1 function, and domain of 1, 1 function is always starts from x coordinate of turning point for these types of functions. So always state the x coordinate of turning point as the value of k. And this is the rough sketch of this function. And see, x is decreasing. Since x is decreasing, so while finding the expression for f inverse, take negative sign. Whenever we have left side of the turning point, left side, then x is always in decreasing. Therefore, always take negative sign in inverse functions. See, I will take inverse sign here. So while finding the expression for f inverse, you have to take negative sign. Why? Because x is decreasing. whenever we have this type of curve or this type of curve, then we always take negative sign. And whenever we have lesser sign here, lesser sign means x is decreasing, so we take negative sign. So this negative sign thing is very important, and I took this negative sign because of this domain. According to this domain, x is decreasing. So for f inverse, you have to take negative sign here, and then you need to replace this x by f inverse and this y by x. Let me edit this. This is the repetition, so let me just edit this. So replace this x by f inverse and this y by x. This is the expression of the f inverse. So you should be careful regarding this negative sign and this y. So to find the expression of f inverse, first you need to observe the domain or the curve or both. According to given domain, x is decreasing, so take negative sign while taking square root on both sides, and then at the end replace x by f inverse and y by x. What if we need domain and range of f inverse? This is very simple. So we have the domain and range of f. So with the help of this domain and this range, we can easily find the range and domain of f inverse. See, the domain of f will become the range of f inverse, and the range of f will become the domain of f inverse. So you just need to replace this x by f inverse. If you will replace this x by f inverse, you will get the range of f inverse. And for the domain of f inverse, you should replace this f by x. So always state the domain and range of f while finding the range and domain of f inverse. So with the help of these two results, you can easily get the range and domain of f inverse. The next topic, transformations of functions. The first topic is translation. There are three types of transformations in our syllabus. Number one, translation. So if we have this as the equation of object and this is the translation vector, then to get the equation of image, we need to replace this x by x minus a, and we need to add b into resulting equation. So first replace by x minus a and add b. And this translation vector means a units to the right and b units to the up, and we use head to tail rule for the drawing or for the sketch or graph of the resulting function. What if equation is given and if the question is identify the transformation? So this means minus p and this means q. So this is translation. This means translation with vector minus p and q, and use head to tail rule for the graph of resulting function. Reflections, type 2 transformation. In reflections, we get mirror image. The object and image are congruent. So, number one, reflection about x-axis. When we reflect anything about x-axis, we opposite the sign of y-coordinate. We change the sign of y-coordinate. Similarly, to get the equation of the resulting graph, we need to multiply y is equal to f of x with negative sign. This is the equation of the resulting graph. This is the equation of the object. So if you will multiply this equation with negative sign, then you will get the equation of the resulting graph. This is the equation of the resulting graph. So if this is the equation of object, so by multiplying this equation with negative sign, we can get the equation of resulting graph, which is y is equal to minus x square. Reflection about y-axis. This is very simple. When you reflect anything about y-axis, you opposite the sign of x-coordinate. And this is the equation of the object. So you just need to replace this x by minus x. This is the equation of the resulting graph. So if this is the equation of the resulting graph, and this is the example. This is the equation of the object. If you need equation of resulting graph when this is reflected about y-axis, then you need to replace all x occurrences by minus x. So replace this x by minus x, this x by minus x, and this is the equation of the resulting graph. Just remember this thing. Replace all x occurrences by minus x. That's it. Stretch. Number one, horizontal stretch. Factor a and x is equal to 0 means y-axis is invariant. In horizontal stretch, we use the reciprocal of stretch factor while finding the equation of the resulting graph. Always use reciprocal of the stretch factor. Like if this is the equation of the object, then by replacing this x by 1 upon ax, we can get the equation of the resulting graph. But while finding the coordinates of the image, we multiply x coordinate with this same stretch factor, ax. We don't take the reciprocal of this here. Because this stretch factor means, for example, if this stretch factor has value 2, then this means the object, the image will be double horizontally. Means if this is the object, then its size will be double horizontally. So we multiply x coordinate with this same stretch factor to get the coordinates of the image. But while finding the equation of the resulting graph, we multiply this x with the reciprocal of the stretch factor. I discussed these things in detail in my lecture of stretch and summary of transformations. You should watch my lectures on transformations of function and especially summary of transformations of functions to be good at these concepts and these topics. Vertical stretch. Vertical stretch, factor A and x-axis invariant. In vertical stretch, we use the same stretch factor to find the coordinates of the image and equation of resulting graph. We need to multiply this y with the same stretch factor to get the coordinates of the image, and we need to multiply this f of x with the same stretch factor to get the equation of the resulting graph. So we use same stretch factor throughout in vertical stretch. So if this is the equation of the resulting object, and if this is the stretch factor A, then this will be the equation of the resulting graph. We just need to multiply this with the same stretch factor. This is the summary of transformations. We have two types of transformations, horizontal and vertical. So in horizontal we have, this is horizontal translation. Number one, reflection about y-axis means horizontal translation, horizontal transformation, and horizontal stretch. So if we have this thing, we need to replace this x by x minus a. Reflection about y-axis means we replace x by minus x. Horizontal stretch factor a, we use the reciprocal of this factor here. But for coordinates of the image, we use the same stretch factor. Only in equation we use the reciprocal of this. Vertical. So there are three vertical transformations. Translation, this is vertical translation. So you just need to add b here. Reflection about x-axis means you need to multiply this equation with negative sign because you change the sign of y coordinate. Vertical stretch factor A, you just need to multiply this equation with the same stretch factor. And same thing with the coordinates. If we have x comma y, and if this is the stretch factor, then you just need to multiply y coordinate with a. We use same stretch factor while finding equation and coordinates. Here we use reciprocal of the factor here for the equation and same factor for the coordinates of the image. Combined transformations. So there are three cases in combined transformation. When we have two vertical, then we use P1’s to apply these two transformations. P1’s means normal order. We first do multiplication and then we go for addition. So what if we have vertical stretch factor 3 and translation 0 minus 2? This is vertical translation. So first we need to do multiplication. In stretch is multiplication and translation is of addition. So first we need to multiply this equation with 3. And then we have to add minus 2 into resulting equation. So first do stretch and then do the translation. So 3f of x, this is stretch, and then add this minus 2 here. So first do multiplication and then do addition when we have two vertical. And this is according to P1’s, the normal order. This is the equation of the resulting graph. But when we have two horizontal, like this, translation, horizontal, and reflection about x-axis. Reflection about x-axis is the vertical horizontal transformation. Let me just correct it. Translation and reflection about y-axis, because reflection about y-axis is horizontal. We just added it. Because when you reflect something about y-axis, then this means horizontal transformation. I made a mistake. Let me correct it. So when we have two horizontal, then we have to use the opposite order. Opposite order with respect to the normal order means first do addition and then go for multiplication. So translation, horizontal, and reflection about y-axis means both are horizontal transformations. This is of addition and this is of multiplication. So first do this and then do this. So when you will apply this vector onto this equation, you will get this thing. You need to replace this x by x plus 3. And then you need to do this reflection about y-axis. For that, you need to replace x by minus x. This is the way we perform reflection about y-axis. We replace x by minus x. So this is the equation of the resulting graph. When we have HV, so we can do it in any way, either HV or VH. For example, if we have this translation, horizontal and vertical stretch factor 4. So we have both the ways. We can first apply this and then apply this, or vice versa. So I'm first applying this stretch factor onto this equation. So y is equal to 4 times f of x, and then I'm applying this translation here. You can do this in other way. You can first apply this. When you will apply this first, you'll get x minus 5, and then when you will apply this, you'll get the same equation. See, both equations are same. So when we have HV, we can do this in either way. This question is very important. We have to describe the given transformations. So try to convert the object's equation into resulting equation, but before that you need to observe the transformations carefully. You need to observe both the equations carefully to identify all types of transformations. So this means vertical translation. This minus 3 means horizontal translation. And this 2 means horizontal stretch factor half. We use reciprocal of the factor. And this means vertical stretch factor 4. Now you have to describe this in this very carefully. So we have these transformations: vertical, horizontal, horizontal, vertical. So we have to perform this in this way. I mean, these are the transformations, so this is the order. First, apply this vector. When you will apply this here, you'll get x minus 3. In fact, you have to first apply this thing, 2x. So when you will apply this here, you'll get, let me check this will be x minus, yeah, exactly. First you have to apply this. Let me do this here. When you will apply this first, you will get x minus 3. See, this will be x minus 3. Then you have to apply this horizontal stretch. So you will get, factor is half, so you have to write 2 here. You need to replace x by 2x. Then you need to apply this vertical stretch, which is 4 times f of 2x minus 3. And then finally you need to apply the vertical translation, which is 2. See, so you can explain this in this way. Translation. This is the description. Vector 3, 0 followed by horizontal stretch or stretch parallel to y-axis, factor half followed by this one, vertical stretch or stretch parallel to y-axis, factor 4 finally followed by translation vector 0 2. So this is the way to describe this. When we have four different types of transformations, then first identify the types of transformations and then make the order. So we have this. So in horizontal we first do addition and then we go for multiplication. In two vertical we first go for multiplication and then we go for addition. So this is the way. You can check the answer. This is translation 30 followed by horizontal stretch factor half followed by vertical stretch factor 4 followed by translation vector 0 2. Now how to describe this equation? So first compare both the equations and identify the types of transformations. This is translation vector 0 minus 3. This is also translation vector minus 90 0. This is horizontal stretch factor half. This is vertical stretch factor 2. So you have to describe this in this way. Horizontal, horizontal, vertical, vertical. In two horizontal we first go for addition and then we go for multiplication. In two vertical we first do multiplication and then we do addition. So this one, first describe this. So you have to say translation vector minus 90 0 followed by this one, horizontal stretch factor half followed by this one, vertical stretch factor 2 followed by this one, translation 0 minus 3. So this is very simple. What if the question is sketch this for the given domain? So to sketch this you have to make the table. This is the best way to sketch trigonometric functions of transformation types. Next topic is AP and GP. Well, for three consecutive terms in AP, for example T1, T2, T3, we use this formula of T. This formula will make the calculations very simple when three consecutive terms are given. So always use this formula to make the calculation simple and fast. This is the structure of AP. First term is A, second is A plus D, 10th is A plus 9D. See, this number is 1 less than with respect to term number. So T4 is A plus 3D. What if I ask you write T50? So it should be A plus 49D because this number is 1 less than with this number. GP. So for three consecutive terms of GP, like T1, T2, T3, always use this formula. T2 upon T1, T3 upon T2. This formula will make the calculations very simple. And this is the structure of GP. A, AR, AR2, AR3, AR13. See, this number is 1 less than with respect to term number. So if this is 14, this should be 13. If I ask you write T50, you should write AR49. This is very important. For converged GPs, modulus R should be less than 1. And this means R lies between minus 1 and 1. So when R is 2, the GP is not converged because R is outside this range. When R is outside from this range, then GP will not be converged. When R is within this range, like minus half, for example, R is minus half. When R is, let's suppose, 2 upon 3, then the GP will be converged. Converged GP means sum to infinite will exist. This means sum to infinite will exist. And S infinite only exists for converged GPs. Let's suppose these are three consecutive terms, first three consecutive terms of a GP, and this is the domain. And the question is, explain why this GP has sum to infinite. For that, you need to first write this thing, the minimum and maximum value of sine. You all know the minimum value of sine is minus 1 and maximum is 1. So, and R is sine theta. because this upon this is sine theta. T2 upon T1 is sine theta. So you can replace this by R. So since R is in this range, therefore sum to infinite will exist. Binomial expansions. Well, this is very important. When we have negative sign here, then we expand the expansion with alternate signs, and we do not consider this negative with the second term here. We take second term positive. So while using theorem, we handle this sign by expanding the expansion with alternate signs. But while using this formula, we take the negative sign. We do take the negative sign of this second term. So make sure you do not take negative sign of the second term here while using the theorem, but while using this formula, always take second term with its sign. And NC1 is n upon 1 factorial, NC2 is n minus 1 over 2 factorial, NC3 is this. Because we have 3 here, so 3 factorial here. And we have 3 terms in numerator in descending order. This is 1, so 1 factorial and 1 term in numerator. 2, so 2 factorial and 2 terms in numerator. Independent of x or constant term, they both means x power 0. Circles. This is the standard equation of circle with center at origin and radius r. And this is the standard equation of circle in completed the square form with center at AB and radius r. And this is the expanded equation of circle, standard expanded equation with center at minus f and minus g and minus f. And this is the formula of the radius. So make sure you know all 3 equations with center and radius. This one is very important. This equation has center at minus g and minus f, and this is the formula to get the radius. Coordinate geometry. For perpendicular lines, always use this formula. To prove that lines are perpendicular, use this formula. If this formula is verified, then the lines are perpendicular. If we know the gradient of first line, so we can easily get the gradient of second line with the help of this formula. The gradient of the perpendicular line is the inverse reciprocal of this gradient. The inverse reciprocal of this is minus 3 upon 2. Perpendicular bisector. Perpendicular means makes 90 degree and bisector means divides into equal parts. So this is the perpendicular bisector. Because this line divides AB into equal parts and makes 90 degree with the line AB. And how to get the equation of this bisector? This is very simple. First get the midpoint of AB, because this midpoint is the common point of these 2 lines, and then find gradient of AB, and then take its inverse reciprocal to get the gradient of bisector. For vertical lines, always use gradient 1 upon 0, because if line is vertical parallel to y-axis, then its gradient is infinite. And instead of infinite, for calculation we use 1 upon 0. Use this. For the fourth vertex of square, rectangle, parallelogram and rhombus, always use midpoint formula. Their midpoint, diagonal's midpoint is same for all these 4 quadrilaterals. So if we need the fourth vertex and if we know all these 3 vertices, then with the help of this formula we can get the fourth vertex for all these 4 quadrilaterals. This formula is very important. For area of triangle, we use this formula A, B, C, and we repeat the first coordinate. Coordinates of first point here. Circular measure. These are the formulas for sector, and make sure your calculator must be in radian mode while using these formulas. This is the arc length, radius, and this is the angle theta. Well, if we need angle of rotation for regular polygons, so this is the formula of finding the angle of rotation. 2 pi upon order of rotation. For example, if we need angle of rotation of this equilateral triangle, this is an equilateral triangle. So if we need angle at center, let's suppose this is the center. This triangle is equilateral. This diagram is not drawn to scale. If we need this angle or this angle or this angle, then we need to use this formula, this one. So it should be 2 pi upon 3, because equilateral triangle has order 3. So we can easily get this angle. This is 120. 2 pi upon 3 means 120. So 2 pi upon 3, 2 pi upon 3, 2 pi upon 3. So we use this formula to get the angle of rotation for regular polygon. And you know this conversion, when you open cone, it transforms in the form of sector. Or when you fold a sector, it forms the cone. It transforms into cone. So this arc length of the sector transforms in the circumference of the base of the cone. So S will become this. Let me add it one thing. This is small, capital R. This is the slant height of the cone, and this is the radius of the sector, and this is the arc length. S is equal to r theta, and this is the circumference of the cone. So arc length converts in the circumference, like S is equal to C. Therefore this r theta is equal to 2 pi r, and this radius of the sector converts in the form of the slant height of the cone. So this r is equal to L. So make sure you remember these two transformations of these two relations of sector and cone. Trigonometry. Well, we know this identity, sine square theta plus cos square theta is 1. And if we make sine square theta subject from this identity, we will get this 1 minus cos square theta, and this is the factorized form of 1 minus cos square theta. Similarly, we can make cos square theta subject from this identity, and this is the factorized form of this. And the formula of tan theta is sine upon cos, and formula of 1 upon tan is cos upon sine. Solution of trigonometric equation. Now this is very important. To solve these types of equations, always convert this domain into this angle. Make this domain as this angle. Unless you make this of this form, you won't be able to solve this equation correctly. So first you need to multiply this by 2 according to P1’s. So you'll get this domain. So 2 theta 0 720. Now you need to bring minus 80 into this domain. You need to make this as this. So 2 theta minus 80 minus 80, and this will be, I guess, 640. Now you have to work according to this new domain. This means you need to work in clockwise direction, but within this quadrant, fourth quadrant. And this means you have to work almost twice. So first convert the domain into this angle form, and then understand the meaning of negative domain and positive domain. Now while inversing, you have to ignore this negative. So when you will take inverse, then ignore negative sign, because you are working for basic angle. Whenever we work for basic angle, we ignore negative. So the answer is 30. This answer is exact, so you don't need to change this number. You don't need to write this as 30.0. This is wrong. When answer is exact, just leave it as it is. Now the first answer will be 30. This one. This is here. The second answer should be this one, 150. The third answer will be this, 330. Now for the second cycle, add 360 into these two answers. So when you will add 360 into this, you will get this. When you will add 360 into this, you will get this. But this answer is out of this domain, so you need to ignore this one. And the rest are fine. Now solve this equation for theta. For that you need to bring 80 on right hand side and then divide your answer by 2. So these are the final answers. You can check the solution again. First change the domain and then understand the meaning of the domain. Then you should observe, you should take inverse carefully, ignore negative, then write all the answers according to this new domain. And check your answers. Check these answers with respect to this domain. Sketches. When we have negative coefficient, we make inverted curve like this. But since domain is 270, 0 to 270, so we have to stop here like this. And the amplitude is positive too. If the question says state the amplitude, then you have to write amplitude is positive too, because amplitude is distance. What if we have to sketch this equation, power 2? Then the best way to sketch this equation is use box. Just make a table and then sketch this. You can easily sketch this equation with the help of these values. And if the question is state the range of this, since a is negative, so this is the formula of the range of power 2 function of cos and sine. If power function has power 2, then use this formula for the range, because a is negative, and vice versa. Well, this is all. I hope this lecture will help you to organize your whole work of P1. An important advice for me and for everyone: think before we speak. Good luck to everyone. And I am extremely thankful to my best student, Miss Iman Anwar, who helped me to make this lecture. Indeed, she is an outstanding student. And she is a genius. May Allah Pak bless her with great success. Ameen. Allah Hafiz.